Hey everybody, I'm going to do a lesson today on lunar phases. I'm going to have you copy some notes. So what I need everybody to do is in their Chromebook, open up a Google document to take notes. Title the notes Lunar Phases. All right, so please do that right now. Okay, this video is going to be posted on YouTube and on Schoology, so you can go back and watch it at your own pace and at your own time or leisure. Okay, so lunar phases. Let's first start with moonlight. What is moonlight? So obviously it's light from the moon, but how does it get that light? Well, some of you might know the answer already. Moonlight is actually sunlight that is reflecting off of the moon's surface. So the moon kind of acts like a giant mirror. So the rocks on the moon's surface have a decent amount of reflectivity, which means they reflect light, and light hits those rocks, and then they act like a mirror, and they bounce off of those rocks to Earth. Okay. All right. What percentage of the moon is always lit? And the answer is half, 50%. Same thing with Earth. The half that's lit for Earth is what we call daytime. So half of Earth is always in day. The other half is always in night. The same thing's true for the moon. Half the moon's in day, the other half's in night. All right? When we see the entire daylit side, that's what we call the full moon. When we see the entire night side of the moon, that's what we call the new moon. And every other phase is something in between the full portion and the no portion, all right, or the new portion. All right, in a normal lesson, I would pause for some questions, but if you guys have any questions, please feel free to email me, and I'll answer them as soon as I can. All right, next slide. So why does the moon appear to change phase? So we played an animation yesterday showing lunar phases. And what's crucial is the moon must go around the Earth. We call this lunar revolution. So lunar revolution, the moon revolves around the Earth. So I'll give you some time to write all this down. So the question you're wording is, why does the moon appear to change phase? If you want to put in parentheses next to phase, phase is shape. Okay, so why does the moon appear to change shape? Because of lunar revolution, moon revolving around Earth. Okay. So what ends up happening as the moon revolves around Earth, different portions of the lighted side of the moon become visible. Half the moon's always lit. That doesn't mean that half is always facing us. So as it goes around us, different portions of that lighted half then become visible. That's what that is saying. Okay. Now there's a hyperlink on this little Earth icon. It's what I played yesterday. I'll play it one more time because it's very important to visualize the lunar phases. Okay, it's easier than just studying the diagrams on paper or a picture. It's nice to actually see it. So I'm going to play the same exact clip I played yesterday. Okay, I'm going to go through it a little bit faster. Or maybe not. Can't fast forward it. Okay. So when the moon is in this position right here, none of the lighted side is facing Earth. This is what we call our new moon. But then the moon will begin to orbit the Earth. Okay, and as it goes around, it it will slowly start to grow. A growing moon is what we call the waxing moon. All right? And it always grows from right to left. So whenever the right is growing, that means it's returning, right returning to full. So as it keeps on going around us, it keeps on growing. And eventually it will grow to full. Okay, which it did right here. So from new to full is what we call the waxing phases. That just means it's been growing, and it does that for half the cycle. So you went halfway around. Okay, the whole cycle is about a month. So half a month is 2 weeks. See, 14 days. All right. And after it's full, it has to start to shrink. Shrinking moon is what we refer to as a waning moon. So then it begins to shrink. And this time, it's the left that we see. So it looks like somebody is erasing the moon from right to left. But the left is what is the last to go. So we say left, leaving. So if you see the moon lit on the left, the moon is leaving every night or returning to new. Okay, it's disappearing. Right, so this is only happening because the moon is going around Earth. So this is called lunar revolution. So if the moon didn't orbit Earth or revolve around Earth, we wouldn't have phases. And there we go. We're basically back to the new moon. All right. And then it starts all over again. Right there. Okay. All right. So I wanted to make sure I played that one more time for you. Let's go back to the notes. So this is where we left off. As the moon revolves around Earth, different portions of the lighted side become visible. So how long does it take the moon to go through all of its phases? I forgot if I had this saved in here. Nope. I guess I got to write it. We're going to get a little exact here. It takes 29.5 days. Okay. That's why half the months have 30 days. So it's not exactly a month. It's a little short. Okay. 29.5 days. If you could say, or about a month if you want, that's fine. All right, the next question. How long does it take the moon to revolve around the Earth? Well, common sense should tell you it's the same answer as the question before. But of course, not everything could be that simple. And it's a little bit different. It takes 27.3 days. Okay? So they're not the same answer. I'll give you a little bit of time because I might be rushing. I'm not with you in class to judge your pace right now. So the two questions again. How long does it take the moon to go through all its phases? It takes 29.5 days, or about a month. How long does it take the moon to revolve around the Earth? It takes 27.3 days. Okay? So this leads to, hopefully, some curiosity. why aren't they the same? Those two questions, why weren't they the same answer? Right? That's what this is asking right here. If lunar revolution is the reason the moon has phases, then why doesn't it take the moon 27.3 days to go through all its phases instead of 29.5 days? Okay? So why? Moon going around Earth is why we have phases. It takes the moon 27.3 days to go around the Earth. However, it takes about 2 extra days to go through all the phases. So my question to you is why? Why isn't it the same number? And the reason is because Earth is also moving in its orbit. In its orbit in the same direction that the moon orbits Earth. This causes a delay. Because the Earth is also moving in its orbit around the sun. Let's be clear about that. Orbit around the sun. So if you're understanding what I'm saying, it's kind of like a game of catch-up in a way. You have two different cars racing in the same direction. So the Earth is moving around the sun at the same time the moon's moving around Earth. And since they're going in the same direction, the moon has to catch up a little bit every lap it takes. So it's about a 2-day delay. All right. So if Earth never moved, if Earth just had day and night, let's say, like just rotated and didn't revolve around the sun, then the numbers would be the same. Okay. But since the Earth goes around the sun in the same direction, there's a slight delay. Okay. All right. I have one more think about it question. Some of you might be aware of this, some might not, but we always see the same side of the moon throughout human history. Not just human history, basically moon's history, really. We've always seen the same side of the moon. So like every full moon you see your entire life is always the same. All right, we never see the other side of the moon, which we refer to as the dark side of the moon. So the same side of the moon is always visible to us, but one side is never visible to us. Okay? And this confused people for a long time. We used to think that the moon didn't rotate, just causing the same side to face us. But really what's happening is it takes the same time for the moon to rotate as it does to go around Earth. So the moon's kind of locked in place. It's as if Earth's gravity has grabbed a hold of the moon like this and just dragged it around us. So the same side is always, like imagine someone grabs you by the shoulders and starts pulling you around them. You're always going to see the same side of that person. That's kind of how Earth's gravity has grabbed a hold of the moon. All right. Now it does rotate, but it does it at the same exact time as it takes to go around us. So the answer is the period means length of time. The period of lunar revolution is equal to the period of lunar rotation. Okay, so that's just saying it takes the same time for the moon to go around Earth as it does for the moon to rotate once. So if you want me to put that in kind of simpler English, I will. It takes the same time for the moon to orbit the Earth as it does for the moon to rotate once on its axis. Okay? And because of that, we are always seeing the same side. I don't know where to put myself here. Same side of the moon. Okay? Now remember, if I'm going too fast, you can go back to this video and watch it at your own pace. Okay? I want to get to one other topic here that I didn't ask in the slides, and I'm going to show it to you in an animation. So most kids at this point, at any age, adults too, are usually curious why we could see the moon during the day. The moon is out just as often during the day as it is at night. So I'm going to show you again with this animation here. Okay? And what you'll notice, I'm going to turn on these time marks. Okay? So we're looking above the Earth from the North Pole. So Earth is going to rotate like this. So this is sunrise, that's noon, that's sunset, that's midnight. So since the moon goes around the Earth, half the time it's going to be on the same side as the sun, while the other half it's going to be on the nighttime side of Earth. So you're going to see the moon during the day just as often as you are at night. Now, it's not always going to be the same phases. Okay? So, for example, here this guy's rotating. When he gets to here, the moon won't be visible because he's facing away from it. But then when he gets to here, that would be moonrise. Okay? Because this person can look and see, well, they'll see the new moon, so they really wouldn't see it on that day. So let me go to some bigger phases. Let's say this one. Okay? So this phase right here, beginning of the waxing gibbous, which is a fairly decent sized phase, would probably be visible at noon. And then highest, look, because he's going to rotate to here at sunset and then actually set at midnight. So then after midnight, you wouldn't be able to see that phase, but you would be able to see it for about 6 hours during the daytime. Okay? Now the phases, as they get bigger and bigger, let's say the full moon, you'll never see the full moon at noon. Watch. Okay? Okay, you'll never see the full moon at noon, or actually during the middle of the day here, because you're facing the sun. See that? But so the full moon will actually be highest at midnight. So here, as this person rotates around the Earth, right there is when the full moon will rise. So next time you see a full moon rising, I guarantee if you turn around, you'll see the sun setting. If you're really understanding what this diagram, you can kind of visualize it. Look at this person standing here. They're at sunset, so they would have to look this way. The sun will be setting to their west, and the full moon will be rising to their east. So I guarantee, pay attention to this stuff. Next time you leave school and you notice a full moon on the horizon, I guarantee if you turn around, you'll see the sunset on the other horizon. They'll be in the exact opposite sides. Okay, so you usually see the full moon right before sunrise or sunset. All right, but it actually would be highest at night, which is why we associate the moon with night. Okay, but I just wanted to show you why we see the moon a lot during the day. So hopefully you get that concept now? Okay. Okay, let's finish up on these notes. Okay, we're going to just write down the notes on waxing versus waning. So if you could create like a little T-chart comparing the two. Waxing on the left and waning on the right. I should have probably switched it the other way around because that's where the light's the opposite side. So waxing, moonlight is on the right side. Waning, moonlight is on the left side. Moon appears to be growing for a waxing moon. And for a waning moon, the moon appears to be shrinking. Okay. They come from really ancient words. So at one time, waxing meant growing, waning meant shrinking. You can always remember waxing because, like, if you wax a car, it's going to glow brighter. So it's literally as if the moon's getting waxed. And every night, it's going to get glow brighter, just like if you wax the car. Okay. It's new moon to full moon for waxing, and waning is full moon to new moon. Okay. And then this is going to be it for the notes for today. New moon versus full moon. So they're very important to know the difference because they come up later on in the unit. We're going to do tides and eclipses. And you really need to know your new moon and full moon. If you mix them up, you're going to really struggle with this unit. So the new moon, none of the sunlit side of the moon is facing Earth. For the full moon, the entire sunlit side of the moon is facing Earth. For the new moon, the moon is in the middle. Okay? That's very important. So between Earth and Sun. And for the full moon, Earth is in the middle. Please try to avoid saying in front or behind. There's no such thing as in front or behind in space. You can always change your perspective. Okay, I can always give you a diagram with the sun on the left. I could just turn the diagram, put the sun on the right. Okay, and also you should never want to say in front or behind because Earth's always rotating. Sometimes something could be in front of you and then 12 hours later behind you, depending on your perspective. So I'm just trying to give you words to avoid. Say middle or between. Try to avoid saying in front or behind when you deal with location or position of things in space. So the new moon is in the middle. Full moon, Earth is in the middle. Okay?
Come from Laurel, Park, and White.
So if you had to draw it,
Come from Laurel, Park, and White.
I guess I can't draw it.
Laurel, Park, and White.
That would be
Come from
your
Laurel,
sun.
Park, and White.
And then
Come from Laurel, Park, and White.
that would be your moon.
Come from Laurel, Park, and White.
And then that would be your Earth. So it would go sun,
Laurel, Park, and White.
moon in the middle, Earth. Okay? M for moon, S for sun, E for earth. And then if it was a full moon, it would go sun, earth. Guess I decided to put the E first. Sun, earth, horrible drawings, moon. Okay? All right. Now, later on, we're going to learn about eclipses. I'm just going to have you write them down now. Okay? Looking at the picture, if you look at on the left here, it looks like the moon can block out the sun. If that happens, that's what we refer to as a solar eclipse. So the new moon could cause a solar eclipse. And the full moon could cause a lunar eclipse. I don't know why it got moved down so much. Okay? So this one right here could cause a solar eclipse. Could, not all the time. They're rare. And the other one, lunar eclipse. Okay? So new moon could cause solar eclipse, full moon, lunar eclipse. All right, that's it for today. All right, hopefully you learned something. See you soon.